Alrighty, let me just close up some of the stuff. Let me close this. Then I'll share my screen. Oh, where's our main scene? It's here. All right. Good day, everybody. Today we're gonna actually do something different, something a little bit different, and we're gonna try to, learn Go together in the next 4 streams, and next 3 or 4 streams, I think. And yeah, we're gonna start from very scratch, from the beginning. And then we will record all of these sessions as we are. They're going to be live on YouTube. So, and I went to ChatGPT just to create a little plan for us, right? So that's what I did. So we're going to essentially follow this thing. So in today, we're going to see where we get, right? But we're going to kind of, we're going to start here and then see where we go. So today we're going to write some Go. And yeah, that's the plan. So we're gonna do something a little bit different because some of the work on Programmer Network I'm doing off stream because it's not very fun. So what we're gonna do today, we're gonna start with Go, right? And starting with Go, right? We're gonna set up the Go environment, install, set up the tooling, etc., etc., etc. So what I'm actually going to do, I'm going to actually go. Yeah, I mean, I've been writing Go already for several years, and we're writing it at Dream Data. But I would like to. This is my favorite language, and that's why I would like to kind of get at least people who watch my streams and stuff a little bit closer to that. So what we're gonna do today is we're gonna start there, and we're gonna go go very slow, and then I think in maybe 3 or 4 streams we'll be able to build a full-fledged API, hopefully. So, so I'm going to create a new directory here that we're going to use for the rest of this. I mean, we're gonna cover all of that, Max, as we go, right? I'm not going to talk about it myself. We're going to go through this process of learning through it. Yeah. So yes. So let's say here Programmer Network. Let me just call it like this: Programmer Network Golang, and we're gonna go into that. And then we're going to open that up. So we're going to start with an empty project here. We're going to use this as our playground to learn this. And yeah, so the first thing we're going to go to official Golang. So this is also a way I often speak about bottom-up and top-down approach of learning. So those couple of streams we're going to have next are going to illustrate how we can actually learn new languages as well, no matter which background we're coming from, right? So now we might learn this, and we're going to have to find a balance in our streams going forward on how to do this, right? In my experience, one of the things that developers do really wrong, many developers, myself included as well, is they neglect official documentation, right? How many people have came to my stream, past years, like, how do I learn React? I mean, if you go to reactjs documentation, right, you can pretty much learn all the React, literally every single thing about it here without ever watching a single video. Because generally, if you do the same with, let's say, AngularJS, you're gonna do the same. They have amazing tutorials, right? Actually, not this, but Angular IO, right? And this applies to everything. If you want to learn this shitty thing, Rust, right, you would go to Rust programming language and learn it there, right? So no matter which language you want to learn, right, you go to official documentation, right? Anyway, so the point is, obviously, we're gonna start here, and let's get kind of started with that. So first thing you want to do, obviously, is you want to download Go, right? If I go to my environment here, I already should have what was it, Go version, right? So I have latest version installed, right? But yes, so you want to download. So I remember maybe 5-6 years ago, setting up Go was a little bit weird. You had to set up Go path and stuff manually. Now, basically, if you want to start with Go, if you want to follow along with me and write some stuff, and I highly advise you to do that, I advise you to do these steps as well. So go to go.dev/dl and get your version of Go for whatever the platform, right? Installing it takes 1 minute, right? So, right. Now, some of you asked why Go and stuff like that. I think the best places where we can explore why Go, right? This is obviously, as you can see, all the platforms that run on Go. So you can see quite a lot of Dropbox. Go is used at Google. It's used at Facebook, obviously, for certain things. Microsoft, Netflix, PayPal, Riot Games like League of Legends and stuff. So Go is a great and arguably currently the best language for building APIs, building infrastructure, working with Docker. It's very native to Docker. It's very native for the infrastructure, for the cloud, right? So we at work use Go, and nearly in every single company where I worked previously, we used Go for infrastructure, for APIs, for things like this, right? I think Leo at the start of the stream asked about difference between JavaScript and Go, and I mean, it's not really comparable. JavaScript fundamentally and naturally used to be a browser-based language. Now, obviously, we have Node.js, but it's not comparable because they solve different problems, right? So Go and JavaScript are fundamentally different because they are used generally for different things. Of course, Go is used to build APIs, to build services, CLI tools, even video games, right? But, it's not really comparable. They're different languages, right? You're not building user interfaces with Go. Right. So use cases, right? So we have case studies. Those are the companies using Go. Then we have use cases here. So what do you build with Go, right? Cloud and network services, as I said, obviously. CLI tools, very natural to build a CLI tool in Go because, Go basically exports the Go binary for you. And then, so it's very, very common, right, to do web development, right? This is what we're going to be focusing on. So we will be basically focusing on these types of things, right? So let's kind of see here. I actually have a couple of books here. I have 2 books on Go. So let me actually just put them here because for the next couple of streams we will need this. So 1 second. All right, actually I have 4 books on Go, and we will see if we can incorporate them. So first one is called Go in Action. This book is my favorite book on Go, but it's a very complicated one. This is called Writing an Interpreter in Go. So basically here you're writing your own language in Go. Then we have The Practice of Programming, also in Go. And then this is probably arguably the best book on Go. It's called The Go Programming Language. So this is the kind of the book that you want to. So this, we're going to probably stick with this one throughout a couple of. Cool. Yeah, Max, this is all already recorded. So all of this is going to be on YouTube, right? Yeah, all right. Microphone is back. All right. Is audio fine now? I think it should be fine now. Yeah, because I usually hit it with my hand. Okay, so let's continue. Let's try to keep these streams, next 4 streams, as. All right, so let's see. Go for web development. Go delivers speed, security, and developer-friendly tools. Go is designed to enable developers to rapidly develop scalable and secure web applications. Go ships with an easy-to-use, secure, and performant web server. Blah, blah. Go has excellent support for all the latest technologies, HTTP2, databases, SQL, Mongo, Elasticsearch, has a TLS 1.3, great. Go web applications run natively on the Google App Engine and Google Cloud. And this is what we're doing at Dream Data, where I currently work. So this is basically very true. For easy scaling, also very true. On any environment, cloud operating system, thanks to Go extreme portability, also very true. This is one of the biggest selling points of Go. It's very portable, very portable. Key benefits for enterprises. Go is preferred for providing rapid cross-platform deployment. We're going to try to skim through those marketing-related things with Go routines, native. Go routines basically is how you deal with concurrency in Go. You have channels, Go routines, and stuff like that, right? Zero-time build. Sako, my friend, good day. Native compilation, URL-based package name spacing, blah, blah, blah. Hello, my friend. Leverage Go out-of-the-box performance, blah, 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 right? So clearly you can see, you can kind of hear, we're going to build some API or APIs soon, and we're going to be actually using it with Cloudflare. So you can see if we actually go here, Cloudflare, as many of you know, is my favorite service. So you can see Cloudflare is also heavily using Go as well, because Go is truly a beautiful language. And then I show you some book that I have. I don't have those. I have other 4 books, and I think the ones that I have are quite amazing. I actually haven't seen these books before, so it's a little bit weird that it's actually super weird that they have these books here, but not the default book of their own. Okay, so going back to this, so hopefully you have installed Go, right? We will start today with the Go Playground, right? So we're gonna go here to learn. Obviously we're going to be using, so we're going to be following something called idiomatic Go. So we have effective Go, idiomatic Go. This is kind of the core. This is a Bible, a Quran, whatever, of Go developers, right? So if you're ever wondering how do you do something in Go, you come here. So if you're ever wondering about anything in Go, you come to effective Go and you read it here. So that's why Go is a beautiful language, is because it's very specific, it's very contained, constrained, and there isn't too many. There's usually one way of doing one thing. So, and that is the difference between JavaScript. In JavaScript, you can declare a function in 3 different ways, right? For example. So we're going to be using this a lot as well. And Numinex, my friend, good day. But we're going to start today with Go Playground, right? So Go Playground is a really great tool to start learning Go, because you don't have to install any tools or anything. So we're going to start with Go Playground. We're going to use the version that they provide, right? Okay, so let's kind of start here and then see where this takes us. I've asked the ChatGPT to generate a plan for us for next 4 streams, because basically I suspect it's going to take us around 3 or 4 streams to get to some knowledgeable point. And we obviously not going to be doing this bottom-up approach the whole time. We're not going to be learning what a variable is, right? So this is not that type of thing, right? So we're going to try to use our existing knowledge and then move along, right? Okay, great. So what we can do, right? we can either execute these things in here, or we can copy paste these examples to our text editor and then run them here. I think that's what I'm going to do here. So essentially, so what we can do here is we can just create a file called main go, right? I'm going to zoom into Oblivion here. And before we do that, so hopefully you have installed Go, but hopefully you have also installed the Go tools in your VS Code if you're using VS Code. If not, so Go has a beautiful support for VS Code. And why learning Go? Because Go is a beautiful language. That's why. So you should do this. You should install this Go Text Explorer, also a useful tool if you're writing tests. There are a few other tools that I have installed, Go Outliner as well. And that's pretty much what you need. Yeah, but Go tools or Go, this is what you want to install in your VS Code. So we can basically copy paste this thing, right? And then we can say Go main Go. And actually, if we do this, it's going to tell us, if I scroll a little bit up, we need to compile our code and then run it, right? I have actually, I've been using Go already, so it's not that I'm learning it, I'm just recording this for YouTube and then trying to illustrate it to also the viewers. So now we can say Go and then main, Go run main. And as you can see now, it's telling us, hey, you haven't imported exactly, Leo. I mean, it's more fun. Okay, so as you can see here, so let's kind of keep it step by step so we can, get to a point, some point, right? So now we have the VS Code. So let's kind of move back here, right? So as you can see, when it comes to Go, so when it comes to 99.9% of programming languages, right? This is good. This is how we're going to start this session of 3 or 4 streams. Every programming language, almost every language has some main file. There's always some file that's a central point of execution, right? There has to be some point, right, where that you have to run. Some file has to have the right. So C, Golang is arguably influenced by C. The creators of Go, they neglect that, but there's a lot of syntax. There's a similarity between Go and C and C++. So this is a fairly simple syntax, right? And as you can see, at least in their official example, there's no semicolons and stuff, so that would make it different than C or C++, right? Anyway, so if we run this program here, I think I zoomed out too much. You can see actually here that I wonder if we can you can see here it said program exited and it printed hello, and then I don't know what language is this, some Asian language, right? So as you can see, every program in Go has to have package main. You have to import in this context, this FMT is a package. Go has packages, just as like in JavaScript you have modules, in our case node modules, in the context of nodejs, for example. In Node you have packages that you import them by using the import keyword, and then you say the name of the package, but we're going to get to that. And then we have a main function, and every Go program has to have a main function, right? So that is no different in C and in many other languages, right? You would have the same, you would have a main C file in C as well, right? So that's great. So how do we proceed further on? So as you can see here, yeah, that's not actually what I want. So where is, did they change this, or do I, okay. Yeah, but this is not the playground I wanted. At least this is not how the playground was before. Let's try to, what's a tour of Go? Sorry, this is what I wanted. This is what I wanted, my bad. So let's switch to the dark theme and let's start. So as you can see, this is actually, so I want us to start with this, and then we're going to start, yeah. So, all right. So this is what I want us to use, and this is the best place to start learning Go, and this is what we're going to actually start with. So of Tour of Go, using Welcome to the Tour of Go, you can also, by the way, download this stuff if you want on your computer, but we will not do that. We're going to do it here. Welcome to Tour of Go. Learn how to use this tour, including how to navigate, basics, blah, 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 blah. So I think if we start here, we're going to start. I don't know if this is an actual starting point. Let me see. I believe it is. So that's where we're going to start. Let me see. Okay. I think it is. So let's go. So this is Welcome to a Tour of Go programming language. So the tour is divided into a list of modules that you can access by clicking a Tour of Go on the top left of the page. You can also view the table of contents at any time by clicking the menu on top right of the page. So if you click here, you can see where this thing takes us, right? Etc. etc. So let's make sure we find a balance between bottom up and top down approach, so we don't spend too much time reading this, right? But I think it's fun if we read this together, because the most boring thing is sitting home and reading documentation, right? So that's why I decided next 3 or 4 streams that we learn this together, so it's fun for everybody, so you don't feel, none of us feel just sitting and staring at the screen alone, right? So let's kind of start. Let's start doing this. So again, and hello everybody. Good day, good evening. So as I said before, every Go program has a main function. Just like most other languages, it has modules and packages. In this case, this is a format package. So format is a module, a package. Print ln is a method or a function. You will notice that this print starts with a capital P letter. We're going to discuss that later. There's a reason why this is a P, because in Go, unlike, for example, nodejs in JavaScript, you use module exports in CommonJS, or you use export default with the ESM, right? That means you're exporting something to be public outside of that module. In Go, if you name a function or a method with a capital letter, that means that the function is accessible in another module. So, and we're going to speak about that. Let's not get ahead of ourselves. So if we run this again, we're going to get a hello, and then whatever this is, hello world, right? All right, so let's go next. Tour is available in several languages, whatever. We're going to be using English, obviously. As you can see here, you can also, as I said a minute ago, you can also do this offline on your computer. So if you're traveling, if you're in an airplane and you want to go through this thing, you don't have the internet, you can also install this using Go, ironically, blah, 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 right? Obi, my friend, good evening. All right, let's move on. So the Go playground, now we're actually starting. So this is just taking us to the point of starting it. So as you can see, this is just explaining how this, how their playground actually works. We don't really care. So let's just move on to starting with this thing. So packages. So let's start here. So every Go program has a package. So let's copy this just here so we can actually see it. And then we'll also set up the rest of the stuff here, right? Dev of web stuff. Dev of web stuff, we're going to take a look at that in a couple of minutes. Please keep it there. Then we're going to take a look at that, just so I don't get thrown away from this flow. So every program in Go is made up of packages. So in most other languages, that is true. JavaScript, C++, C, Python, C#. So this is nothing new. So in every programming language, we write modules so we can then give them some functionality, some responsibility, and then that module is usually composed of functions, and these functions do certain things. So imagine a box, you have a box, and that box has just some tools that you can use in your program, right? Good evening, everybody. So programs start running in package main. So this is your main package. Here we're saying, hey, create a new package called main, and this is the contents of this. This program is using the packages with import paths fmt and mat rand. So this is just like in JavaScript. This rand thing is, you would in JavaScript, you would say mat.random. In JavaScript, this mat is a constructor, but you can also say that's a package or a module. There's many variations of the same word, but they mean the same thing. So a module or a package is the same thing. Namespace is commonly something that's grouping maybe multiple modules or multiple things. But when we say package, if you're more comfortable with a module in the JavaScript world, then this is the same, right? Okay. By convention, the package name is the same as the last element of the import path. For instance, the mat rand package comprises files that begin with the statement package rand. So by convention, the package name is the same as the last element of the import path, right? So in this context, rand. So we know now that what is Go program composed of. Now let's move on. This code groups the imports into parenthesized factored import statements. You can also write multiple statements like this. So basically, this is just a syntactical sugar. Instead of they're saying, hey, instead of saying import fmt, import mat, you can say the import once, and then you can put things in brackets like this, in parentheses, and then just basically list them one after another. So this is basically this statement and this statement, they're basically the same thing, right? So if I remove this and run this thing, it's going to do exactly the same thing, right? So far, if you're following, there is nothing so far that you can't understand. This is just common type of thing, right? And that's it. In Go, a name is exported. This is what I was talking about a couple of minutes ago. So as you can see, exported names. In Go, a name is exported if it begins with a capital letter. So for example, we saw that print line thing. The reason why this P is capital is exactly because of this. For example, pizza is an exported name, as is pie, which is exported from the mat package. Pizza and pie do not start with a capital letter, so they are not exported. This is one of the kind of things one of the very few things that I dislike about Go. I don't think this is explicit enough, hence I'm not a fan of this. I really wish that Go also had a more explicit export statement. So when you read the code, you can actually, just like in JavaScript, right, you're going to go somewhere, usually at the bottom of your module. In CommonJS, you would be like export, module.exports, right? And then you would specify exactly, what are you exporting, right? I find that more readable and more explicit because I hate implicit feature. I'm generally not fan of anything implicit, right? This is kind of in Go, right? For you can define a function like this, func, banana, right? And this function now is by default exported, right? And that to me is not something that I prefer, but that's what it is. There's no language that you can find that does everything the way that you want, right? When importing a package, you can refer only to its exported names. Any unexported names are not accessible from the outside the package. Obviously, logically, you have private and public members, if I may, even though we're not in the context of a class here. And if you don't name a function or a variable or anything really with a capital letter, it's going to be local to that package/module, right? Yes, Leo, that's correct, yes. That's correct, yes. Yeah, so there are a few things. So Sako shared one of the things as well. I think Go team is working on making error handling a little bit less verbose. But again, it really depends how you look at it. So error handling in Go, I think it's very verbose. You're all over the code, if not nil, if not nil, if not nil. But on the other hand, you're gaining, I think that, for example, exception handling in JavaScript is a way worse pattern than handling errors in Go. If I was asked, I would completely ban exceptions, right? I would not allow that pattern to be used. So yes, Go has a verbose error handling. It's all over the place, but it makes you think about errors as a first-class citizens, and this is a very healthy pattern. Because the biggest problem with, for example, junior developers when they're writing JavaScript is that you open a bunch of code bases and there's just console logs. If there's an error, console log. People don't know how to deal with errors because you don't treat them as first-class citizens. In Go, an error is as important in your mind as it's the value that that function returns if it doesn't break, right? So I think the reason why what Go is doing, I believe, is healthy is that you learn from the very get-go to think about errors as something crucial to your program. Whereas in JavaScript, sometimes you're like, who gives a shit? I'm going to just put this in a try catch, and if it explodes, who cares, right? I mean, I'm going to print something or whatever. So you get this fake sense of accomplishment by, as long as I just wrap this whole thing in a try catch, what can go wrong? But then, as I was describing in one of my latest streams, or was it a YouTube video, the biggest problem with exceptions, right, is that if you try and catch 20 different functions in one try, then in your catch, how do you then discover which one of these is the actual error? So you have to then make sure that your error handling is done according to a very articulated strategy where you can then have a switch statement maybe in your catch and say, if this exception happened, do this. If this exception happened, do this. So right, so that's the thing, right? Because in JavaScript, right, like if you want to do the exception handling, if you have try, let me illustrate that. Let's imagine you have try and catch, right? Like this, right? Just so you can understand what I'm doing, right? So let's imagine you have this, right? And then you have function, you have function A, and then you have function B, right? And let's imagine that you're just using that you're throwing a native JavaScript errors from the native error constructor. So you say throw new error, this is an error A, right? And then in a function B, you say this is an error B, right? So why is this bad, right? And then imagine here, you have some business logic and you do this. Let's now imagine that there's a lot more code here. And let's imagine that one of these errors happened, right? What can you do? Now, what you have to do, you have to say if error.message is, this is an error A, handle in some way, right? And then you have to do the same with the other error, right? Error B. You can see this is super ugly because this is very, very error prone as well, because these messages are very commonly changed, they're updated. But now you're basing your entire error handling strategy on what an error message is, which is arbitrary. This text can become something else, right? So this is the problem with JavaScript. You can't really rely on a native error constructor because it's not extensible by some reason or why or whatever. So in JavaScript, what you would generally do, you would create a class called, let's say, custom error. And this is actually fine, but here what you would do, you would say this dot, let's say, reason is, let's say, reason, right? And then here you would say reason, right? Or either reason or whatever, right? They're various, and then you can throw a custom error, right? And then here you can say reason X, right? So now you would be dealing here in exception handler, you would be saying if error.reason is this is less prone to breaking, right? But you can see that it's still, no matter what you do, no matter if you create, you should be creating a bunch of these different classes for different types of errors in your code, still it takes effort, takes different type of thinking with exception handling. In Golang, right, because you treat errors as first-class citizens, you're thinking about the error as much as you're thinking about the value that the function returns. You don't have to think about this way in writing switch statements in your catch clauses or your centralized error handlers, right? Because it's pointless, right? It's not efficient, right? So this is kind of why I think that even though Go has a very verbose error handling, it's still better because you treat these errors as something essential and important for your software to work, because it truly is. It is something that's truly so important, right? All right, so let's move on. So functions. A function can take 0 or more arguments. Very common in any language out there. Exactly the same. As you can see, we have a function called add. So if you wrote this in JavaScript, for example, if you just omitted, or actually if you wrote this in TypeScript, it's almost identical, right? So nothing special. What is the difference between this and JavaScript? Well, in JavaScript, right, you would write a full function keyword, or you would write a function expression or function declaration. So function declaration in JavaScript would look like this, function add, and then you would write a lambda function or even a named function like this. You could call it add again, right? Either way, you can see writing functions in Go is no different than writing them it's almost identical in TypeScript, right? So as you can see, this function has an integer, x, integer y, returns an integer, and then as you can see, it returns the multiplication of x and y, and as you can see, just like in JavaScript, we're invoking a function, giving it some values, and then passing it to the print line, and then the print line is going to execute that thing, right? All right, cool. So functions, we know already how to write. Let's move on. Functions continued. When two or more consecutive name functions parameters share a type, you can omit the type from the all but the last, right? So this is very interesting, right? So what they're saying, hey, because of this function add, is because both x and y are int, you can omit the int from x, is because if all the arguments of a function share the same type, you can just append the type at the end to the basically to the last function argument. So in this context, because both x and y are integers, you don't have to say that both of them are integers. You can just say at the end of this list. Again, I'm always still, even though you can do this, I would always actually write a type because I hate implicit things. This kind of is ironic and paradoxical almost, because I'm mostly a JavaScript developer, so coming from dynamic language, saying that I don't like implicit things is kind of ironic at best. But yes, if I'm writing a typed language, I like it to be fully typed, or otherwise I'm not going to use typed language at all, right? But yes, you can do this. You can basically just omit the int in this context because both of them are integers, right? All right, so we go next. Multiple results. So unlike JavaScript, right? In JavaScript, you can't really return multiple times. So a return statement in JavaScript can only return once. This is kind of a misconception here as well, because this almost feels like it's returning twice. It's really not. In JavaScript, basically, if you wanted to do the swap function that they're talking about here, so they have this function swap, which is going to swap two numbers, right? So you pass x and y, and it returns y and x. In JavaScript, basically, you would do this very similar. You would say function swap, right? But then you would return an object with y and x. Of course, this wouldn't be the same. Or in JavaScript, you could just as well return an array. So you could do x and y like this, right? But syntactically, at least, here it feels like we're returning two values. And actually we are, but it doesn't really matter. In JavaScript, you can do that as well, but you have to return one value, one type. So in this context, either this or this. In JavaScript, you can't do this, right? So that's, I'm trying to as we're going through these streams, next 3 or 4 streams, I'm going to use JavaScript as a reference for many of you who are watching this stream, so you can kind of easier understand. It's always good when you're learning these new things to just say, hey, I have a lot of existing knowledge, so let me not relearn things from scratch, right? So let's just compare, by comparing it to the language that we know really well, I think in Go, right, you would access them like this, right? So you would say A, B, colon equal, we're going to talk about this. You would access them almost like you would destructure them. So that's a good question, right? So let's imagine that, so how would you do this in JavaScript, right? You would do it almost the same, right? In JavaScript, you would just destructure. So if we would call this in JavaScript now, you would do const or let or whatever, and then you would say swap, right? You would call swap, you would call whatever, and then here you would say whatever, x and y, right? So that is the difference. In Go, right? In Go, you would say, just as they wrote here, A, B, right, is equal to swap, right? So you can see the difference with JS and Go would be fairly almost identical. So here we would destructure. In JavaScript, we would destructure because we are returning an array from here. But in Go, you would actually, in fact, get two variables like this. But again, it's all really just syntax, right? So that is fundamentally the difference, right? All right, cool. So yeah, in Go, you can actually return multiple results, and it is actually multiple results, but it's not to say that you can't do this similar thing in other languages. It's just syntactically different. In other languages, you have to return a single value, but then that can appear, right? We're gonna get to this operator. I think let's stay patient. Let's stick to this Go tour, right? Because I want to illustrate through next 2 or 3 or 4 streams the way that you can actually truly learn a language without almost no external resources if one is just patient to follow and stick to the actual official documentation, right? All right, so if we move further down, name the returned values, right? So this is a little bit strange feature, something also that I dislike. So maybe this is the third thing so far I disliked about Go. So as you can see here, name the returned values. Go's return values may be named. If so, they are treated as variables defined at the top of the functions. These names should be used to document the meaning of the return values. A return statement without arguments returns the named return values. This is known as a naked return. So this is one of the things I dislike about the language. I don't think this should have ever been implemented, in my humble opinion, because again, it's too implicit, and I would never write code like this. In JavaScript, if you would do this, the split would return undefined, so it would implicitly do this. In Go, if you do this, this is actually going to return X and Y, right? Naked return statement should be used only in short functions, as with the example shown here. They can harm readability in longer. So you can see here basically that even the Go developers who kind of implemented this, it's kind of almost ironic, because they know, they even wrote it here, that naked return statement should be only used in short functions, as with the example shown, they can harm readability in longer functions. So look, nothing is perfect, right? This is not to criticize it, right? It's just very weird, because what is the value of this? What is it really so difficult to write this, right? And you don't have to use it. I mean, generally, I think most people are not going to do this. It's just weird, because when you design a new language, right? So think about it this way: when you build a new product, let's just compare this to product development. Today when we're building new products, right, we always look at other products. So for example, if you're building a new video game, of course that you're going to see, let's imagine you're building an MMORPG. What are you going to do? Well, you're going to say, well, World of Warcraft was a very popular game. I don't know, this Final Fantasy. So of course you're going to get inspired and try to do things based on what worked. When you're designing languages like this, you're neglecting exactly that other languages do certain things, and then the developers who are approaching the language that you design are going to have expectations. So for example, when a C developer comes to the C++, JavaScript, Rust, Python, whatever, when people come to this, your main expectation here would be that this actually returns nothing, right? It returns undefined or nil or null or zero, depending which language you're coming from. But no, actually, this is going to return X and Y, right? So it's not like, if you haven't read this documentation here to the left, you would think, yeah, this is returning nothing, right? But it's actually returning X and Y. So this naked, it's called naked returns, right? I don't think they should have implemented that, but that's what it is. Alrighty, let's go with variables. The var statement declares a list of variables. As in function arguments list, the type is last. So as you can see here, this is common in many programming languages as well. You say var C, Python, Java, bool. So basically here we are, as you can see here, the var statement declares a list of variables. As in function argument list, the type is last, right? So all of these now things are of type bool, right? If we wanted to define different types, then we would have to use another var statement, right? Var is a very common thing. If you remember in JavaScript, we used var for a long time. There's still some people like Kyle Simpson who is very open to using var. Var statement in JavaScript, if many of you remember, we stopped using it because side effects it would create. It wasn't scoped. So for example, if we, just so I can get you closer between two languages, so in JavaScript, the reason why we stopped using var is because it's not block scoped. So for example, if I come and say if 2 is greater than 1, right? Var x is 22, right? So now if I come here and I print x, and I think I mistyped this, I wrote, so as you can see, I printed x. You can see that the x is 22 in JavaScript, right? Why is this? This is due to variable hoisting, or this is due to how JavaScript interpreter works. So why is this 22, right? Let's write this example again. So why when I print this this x here, why is it 22? It's 22 because before JavaScript executes this program, it does variable hoisting. What is variable hoisting? Variable hoisting is a process of JavaScript organizing your declaration of your variables and functions. So what JavaScript is going to do before it runs this, JavaScript interpreter runs in several stages. One of the stages, it hoists your variables. So what it's going to do here is going to say, hey, I see some var x on this line. So I'm going to omit that thing, and I'm going to define x on this line. And I'm going to just do this. Basically, this is implicitly set to undefined. So what JavaScript interpreter did, it did this. And then it's going to see, hey, there's no more variables for me to declare. So now in the next stage, I'm going to execute this program. I'm going to interpret this. So as you can see at this point, because of variable hoisting, because of variable, this tool is pissing me off. Because of variable hoisting, right? This program now can run. It's not failing because the var is not block scoped. The var is undefined. So we're going to get to this if statement. X is going to get reassigned to 22. And when we get to this point, X is going to be 22, right? So that's why we stopped using var, because it's global scoped. It's not block scoped, right? If we whatsoever switch this value to, let's say, let or const. So if I say here let x is 22, this is now going to hoist very differently, right? So now we're going to, why are we learning Go? Just for fun. We're just doing it for fun. So I need to refresh this. So if we try this again, you're going to see that x is now not defined. So basically, let and const in JavaScript are block scope, var isn't. So anyway, this is just to remind you why we used, how the var worked in JavaScript and stuff like that. So as you can see in Go, var, we define variables using var, right? And I don't want to talk about JavaScript internals. Maybe we can have streams about that. There's a lot of other things that happens during variable hoisting, how function declarations are hoisted, how function expressions are hoisted. So that's a subject that you can find on the internet, I'm sure, anywhere. So in Golang, we say var, and then we separate, we define a few variables, and then we, at the end, if they're all the same type, we say bool. If we wanted another variable, which was a string, you would say name, and then you would say string like this, right? So Tobs, this is more of a YouTube series of videos. So it's more about just recording a course on Go almost by doing it with the community. Variables with initializers. A var declaration can include initializers, one per variable. And this is one of you actually asked about the initializer, I think, recently, but let's see. So how do we actually, so in the previous example here, right, Go, this is how we just declare the values, but we don't give them, declare the variables, but we don't assign any values to them. How do you do it in Go? You do it pretty much the same as you would do it in JavaScript or in many other languages. You say var I, j, int is equal 1 and 2. So I is going to be 1, 2 is going to be j, nothing strange, right? And then what else is happening? So var c, Python, Java, true, false, and no. So you can see here, these three have different types, and the types are going to be inferred, right? So this C is true, so the Go compiler is going to infer the type. This is going to be, hey, C must be Boolean, Python must be Boolean, and Java is a string, right? So you can see a compiler. So again, so you can see that so Go is not really fully strictly typed. And this is in a way what I often dislike. It gives you, so it's kind of, it gives you a little bit of developer experience. It gives you a bit of, I mean, TypeScript does the same with primitive values, right? In TypeScript, if you say const name is Alex, you don't have to specify the string. Of course, you can enforce the TypeScript compiler to enforce this as well. It's just, yeah, I mean, it's kind of this in the middle. Go is in the kind of, it's not that, I mean, even TypeScript is more typed than Go is, right? So Go isn't that, and my pleasure, guys, my pleasure. All right, so let's go. So that's it. This is how we do it. Do I like it? It's very similar to many other languages that I wrote, so it doesn't make much difference for me, right? You can do the same in JavaScript. And good evening, everybody. Okay, so somebody asked about this short variable declarations, right? Maybe a couple of minutes, somebody asked, hey, what is this thing? Inside a function, Brady, my friend, thank you very much, man. Inside a function, the colon equals short assignment statement can be used in place of a var declaration with implicit type. Outside a function, every statement begins with a keyboard var, so the colon equal construct is not available. So, short variable declarations, we can only use them if we're defining a variable in a function scope, meaning I can say k is colon equal 3. We cannot do this outside of a function. So as they say that this construct is not available in a global scope pretty much, right? So what you can't do is you can't say j colon equal 2, right? So you can only do that inside of a function. Why this? Why have this? Again, another developer convenience. This is questionable now in the context of should it exist? Because convenience usually has a side effect. Every single tool when you use in a programming language that's convenient often comes with some pain, right? Is this great? Does this look great? You learn in time to make it look great. But is it necessary? Probably not. Because again, the convenience that these things provide are unjustifiable in my opinion. Because again, saying this or saying var k, right? Let's say, what is this? Int is 3 are the same statements, right? Is this really worth to save you this amount of code? That's questionable. If you ask me, it's not, right? So even Go has few of these little variations of certain things, luckily very minimum relative to JavaScript, of course, but it still has some of these things which to me is very hard to justify, explain, because I don't think that this should have ever existed in the first place. But again, convenience, right? And developers, all of us, we like convenience. We like short, we love lambda functions, we love to write map and reduce in a single line. It feels cool, right? But it feels cool, but is it right? That's questionable. All right. Okay, so let's move on. We're not going to stick to this too much. This is too bottom up. This is too theoretical. So we don't care about the types now, right? So Go being strictly typed, just like any strictly typed language. I mean, of course, every single language has types. JavaScript has all of these types as well. The difference here that we're making is that in JavaScript, they're implicit. So garbage collector and JavaScript interpreter declares these for you. It frees the memory. It consumes the memory and stuff like that. Here we have to be oftentimes, depending on the length of a certain number, a certain string, we need to know upfront, hey, should I use an int 8, 16, 32, 40, 64, depending on the possible expectation of that value, right? So you have to now think, okay, am I storing a number in this variable that's length 1 to 10, or is this going to be an infinite number almost with 10 decimals, right? So this is the difference when you come from a dynamic language like Python, JavaScript, Ruby. In these languages, you don't think about the size of the value because, again, you have tools determining that for you. In languages like Go, you have to say, so because oftentimes, why am I even talking about this? It's because oftentimes these things are explained in a very complicated way. But fundamentally what this is like, hey, Go is now asking you, hey, how much memory should I allocate for this value? Please don't tell me to allocate int64 if you need to store a number that can be up to 2 decimals or 1, right? So this is more about being knowledgeable and efficient in a way how much memory you want to save. Of course, you can always, let's say, you can use int64 for whatever you want. You can forever, but that's not efficient because you're going to be allocating a lot more memory than you actually need, right? All right. So let's read what they wrote here. The example shows variables of several types. Also, that variable declarations may be factored into blocks, as with import statements. The int, uint, and uint pointer PTR types are usually 32 bits wide on 32-bit systems and 64 wide on 64-bit systems. When you need an integer value, you should use int unless you have a specific reason to use a sized or unsized integer type. So we're not going to stick too much to this. I don't think this is fun also, especially for some of you who never wrote any language where you have like C, where you need to either constrain yourself or use unsigned or signed integers and stuff like that. So for the most part, in 99.9% of cases, if you're building APIs, and that's what we're going to be using Go for, to build web servers, maybe some CLI tools, in very rare occasions you would use something other than int, right? Yeah, and then here what they're doing, they are declaring some variables as we saw. So max int, they're using unsigned integer here, 64-bit, and then we'll speak about some of this. Complex numbers, 128. So you can see this is a little bit more complicated for us right now. So we will not be getting into this. So Go, just like every single other language in history, has types, and there's nothing really special about it. Every language has types. Dynamic language, static language. The difference is, in dynamically typed languages, you don't define types. In statically typed languages, you define types. That's the difference, right? Variables declared without an explicit initial values are given their zero value. 0 for numeric, false for booleans. So this is important to know. In JavaScript, so this is important to know oftentimes because this can lead to unexpected consequences in your code. In JavaScript, if you don't provide value to a variable, it's undefined by default. As we say, it's implicitly assigned undefined value. So in JavaScript, if you use var, const, or let, it doesn't matter. You say var x, and you do this x is now undefined. What these guys are saying is, like in Go, for any numeric values, any numeric types, if you declare a variable like this one and you don't give it any value, you don't assign it any value, it's going to be 0. Same here for boolean, it's going to be false. For string, it's going to be an empty string. So this is really good. This is something that you would expect. And I like the default, basically, initial values as they are in Go. I think this is pretty reasonable. Type conversions, we can compare this to JavaScript coercions. So JavaScript type coercion. So this is how we call that in JavaScript, right? JavaScript is very notorious for this. There's even websites, there's memes about this. There's even a website called What the Fuck JavaScript that laughs at this stuff. I can just show you a little bit. So if we find some, so for example, you can see here. So YMIA type of YMA a number. So for example, you can see here 2 plus string of 3 is 23. 2 plus plus 3 is 5. Some of you might find this funny, even stupid. I actually know all of these rules. So there's reasoning behind type coercion in JavaScript. If you want to learn type coercion in JavaScript, Kyle Simpson wrote a book called You Don't Know JavaScript, and he has one of the books that's called Types Coercions. So if you get here, scopes and closures, So it's in here basically. So he wrote a really well defined piece of the book here. If you care about coercion in JavaScript, you should read this. The point that I'm trying to make here is that now we're going to be talking about type conversions in Go, and in JavaScript this is slightly different. So as you saw, y is, for example, 2 plus string of 3, 23, right? Y is this, right? Why these cases exist. And again, even though this is really bad, it's a dynamic language and there are rules behind this, because JavaScript interpreter is gonna assume in this context that you want to some two strings. So it's going to convert this number to string of 2, and it's going to do this. So this is not a number, this is now a string of 23, right? So there are reasons behind it. I'm not going to get into the reasons of this, right? But anyway, in JavaScript, this is it's because the plus sign coerces the string of 3 to a number. So when you say plus 3, what you're doing is you're coercing, you're converting, you're doing a conversion. So this thing is identical if you said parse int and then you said 3 and you gave it the radix here, right? So this is identical almost. I'm not saying it's identical on a low level of a JavaScript compiler. I don't know these details, but this and this is exactly the same. So you're telling the compiler, hey, I have a plus in front of the string of 3. So JavaScript interpreter is going to try to assume that you're trying to convert, you're trying to sum up a string. So it's saying, hey, you probably are using this, you want to use this as a number, so I'm going to convert that, I'm going to coerce that for you, I'm going to convert this to a number of 3, right? So that's why. So that's why when you say 2 plus and then plus 3, you're getting 5, because this expression here is converting it to a number of 3. So that's why. But you can laugh about this, you can shit on it, behave like a 12 years old little asshole, or you can just learn the rules, understand them, and then it all makes sense. Majority of people are more prone to just being morons relative to things they don't understand than yeah. All right. So, but this is not a JavaScript. We're trying to learn Go here. So let's go back to shit. Let's get back to where we stopped. A tour of Go. So how far we were? Where were we? Was it variables, short, basic types, zero values, type conversions. Okay, so now going to Go. So what we just learned about how the JavaScript works. Here we have the expression t of v converts the value v to the type of t, right? So some numeric conversions, var int 42. So you can see in in Golang, just like you would do in C++, for example, you have to use conversion methods to convert one value to another. And I like this. This is how it should be. And in JavaScript, this is also what we do. So you say var f float 64, take this and convert this integer to a floating point number. So make it a decimal number in simple words. Same here, var u, unsigned integer, uint f. So basically convert the floating point number to uint number, right? Chica, my friend. Put simply, if we are using this short declarations, within the function you say I is 42, f is float, blah, blah. Unlike in C, in Go, assignment between items of different type require an explicit conversion. Try removing the float or uint conversion in the example and see what happens. So let's see. So unlike in C, in Go, assignment between items of different type requires an explicit conversion. So basically what they're saying, if you would write this, but you would try to assign this I to a floating point number, this is gonna explode, right? So you cannot assign an integer of, let's say, 5 to a floating point number. You would have to say 5.0 or something like that, right? All right, cool. Let's move on. Type interface inference. Sorry, type inference. This is also I just spoke about this in the context of JavaScript. When declaring a variable without specifying explicit type, either by using the short syntax or var expression syntax, the variable's type is inferred from the value on the right-hand side. This is the same in JavaScript / TypeScript, so nothing should be unclear here. When the right-hand side of the declaration is typed, the new variable is of the same type. So var I int, j, short operator I, j is an int, right? So it's going to infer the type. So you can do this with a lot of primitive types like strings and booleans and in this context numbers, right? But when the right-hand side contains an untyped numeric constant, the new variable may be an int float 64, complex 128, depending on the precision of the constant. So let's try to understand this. I is 42, f is 3 point, so it's a pi. But then g right here it's depending on the expression, it's going to infer the type, right? So it might be one or the other. So that's why, I mean, if you're really working, if you're building a tool where precision is really important, I think, okay, maybe sometimes this would be necessary, but it would probably be better to just be explicit with writing the actual type. Because you can see that this is complex 128 because of this expression here, right? Try changing the initial value of a v in the example code and observe how its type is affected. So if we say here 12.2, you can see it says v is of the type float 64. But if we say 12, you get it, it's going to be an int. So you can see with the primitive types in this context, it's going to infer the actual type. If I say here, Leo, right, and I run this, v is of the type string. So you get the point. So it works exactly the same as it works in JavaScript, in TypeScript, in Ruby, in Python, etc. Constants, just like in most languages, constants are the values that you cannot change once you declare them. So it's the values that you want to remain constant, immutable, as long as your program is running. So this pi is always has to remain 3.14. So constants are declared like variables, but with the const keyword. Constants can be character, string, boolean, or numeric values. Constants cannot be declared using short operand syntax, right? So as we can see here, pi is 3.14. The rest of this logic is irrelevant, but let's just keep this very simple. Just like in every single other language, what's important to remember here, constants are constant, they cannot change, and you cannot declare them using short operand. So you have to use var and declare them as such, right? Okay, now the most important question is idiomatic go camel case or snake case for variable names. And there was another question. Can someone reassign the type of a variable that has no explicit? Yeah, I mean, as you can reassign it, yes. Now the most important question is idiomatic go camel case or snake case. I don't actually know Numinix. I don't know I don't have the response to that question. Numeric constants. Numeric constants are high precision values. An untyped constant takes the type needed by its context. Try printing need int big 2. An int can store at maximum 64-bit integer and sometimes less. Let's see what this is. Create a huge number by shifting a 1 bit left 100 places. In other words, the binary number that is 1 followed by 100 zeros. We're gonna skip this. This is a little bit far ahead. It's a little bit weird that they've added this now. This has its own context. For now, we're gonna skip this. Let's just not worry about this. We will not be dealing with, in our tasks we're not gonna be dealing with this for now. So I would leave this, if you care about this, I'm gonna leave it to you. We will not be using these big numbers, so we don't really need to talk about shifting pointers and stuff like that. So let's just I would say Numinix. I can maybe probably give you the most accurate answer to that. I think in that, for your question, right? For your question, to answer your question, right? I think in that context, anything that you agree with your team is idiomatic, right? So I mean, as long as you are constant or consistent in your style, that would be idiomatic thing, right? You finished this lesson. Great. Okay, you can go back to the list of modules to find. Okay, let's see what happens if we click next. So now we are into actually writing some things, right? And there's 14 lessons here, so actually soon when we go through all of this, we're going to start writing some code, right? So, but we have to go through those basics, right? That's just to familiarize ourselves with syntax. So we're not learning really anything new here in that sense. We all know what a loop is, what a function is, what these bottom-up pieces of programming are, but let's just... okay, Go has only one looping construct. So this type of information is good to know. It's like, because in JavaScript you have 15 different ways to loop through things. You can do it through, you can use reduce, for each, map, sum, values, for in, etc., etc. In Go, so this is the information. So what are we extracting here, right? So what am I trying to convey here? When you're learning a new language, you want to compare it to the language that you know. So the most essential information for us here is to know, all right, there's one way to loop through things. Now, of course, we can write abstractions even in Go to loop through things in 10 different ways. But the language itself provides one way. You can, of course, write your own functional libraries in Go, like you have in JavaScript. You have a lambda.js, Lodash, and stuff like that. That's not the point. The point here, the language exports provides a keyword for, and that's how you write loops in Go, right? So the basic for loop has 3 components separated by semicolons. The init statement executed before the first iteration, the condition expression evaluated before every iteration, and then the post statement executed at the end of every iteration. So this is, if you ever wrote C, if you ever wrote JavaScript, it's the same thing. In JavaScript, right, we would almost write this in the same way. So you would say for var x is 1, x is less than 5, you know, x plus equals 1, or x plus plus. This would basically run how many times? Then you would print x, right? This would run, right? So it's almost the same in Go. We initialize the variable. We have the expression for which this loop is going to run, as long as this expression is true. And then at the end of each iteration, we increment x. You can write this a little bit simpler in JavaScript as well. You can move this thing at the bottom of the for loop so it's more explicit, it's clear. So print the console, increment the x. So you can also do this, right? And it's going to do the same thing, right? So you can kind of see that, so that's very similar in Go. So going back here, we initialize the variable, we have the expression, and then we increment the I, and then in this context we just sum up. So you can see plus equals really, first time I wrote this in my career was when I was writing C when I was very young. Plus equals was a very common thing. Also was I++, and C++, you're going to see this a lot as well. So this is just how it is. The init statement will often be a short variable declaration, and variables declared there are visible only in the scope of the for statement. This is very important, right, for us to decipher, because you remember I explicitly now wrote, I explicitly here used for var x just to demonstrate this. You see, in JavaScript, if you're writing the loop like this x now, because it's declared using a var keyword, leaks out of this for loop. It's not scoped to the loop itself. So if I come here and print the x is x, you will notice that in fact the x did leak outside of this loop, which is also why we stopped using var. Now if I replace this with let, right, we cannot replace it with const, obviously, because const wouldn't be able to increment itself. You can see now, and I have to refresh because it's using the x from the before. So if I refresh here, you'll notice that this is actually going to fail now. It's going to fail because, hey, it's saying x is not defined, is because this x now is only available inside of the scope. Why am I saying this? I'm saying that because exactly that's how the Go works. It says the init statement will often be a short variable, and the variables declared there are visible only in the scope of the for statement. So this I in this context, this one that we declared here, is only accessible inside of this loop, which is what you would expect. You would not expect this thing to be scoped out. If you wanted such a feature, you would then have to declare your x outside. So let's imagine that you wanted this x for whatever strange reason to be accessible outside of this loop. Sure, you can do that, but then you would say, you know, let x 0 here. And then here you would just say, for example, x, right? But this is the difference between implicit and explicit code. In the explicit code, you explicitly define your intent. Hey, it was actually my intent. I want this let to be accessible in some global scope, regardless where this is defined, versus assuming that this x might leak out somewhere else. So that is the difference, right? No, the const isn't mutable. The const isn't mutable. I think you're conflicting that is because you're probably talking about objects. A lot of people, when they do this, they are thinking now that this object is immutable. But this is not true, right? This is a constant, meaning that this a cannot now be redeclared to 2. But you can still reassign the value of b to something else, right? So this is the difference, right? So a lot of people are conflicting what a const is. This const now, because we defined a complex data structure here, an object, this const a holds a reference to this object somewhere in memory. But that doesn't mean that the object itself is immutable, right? So this is the difference, right? So of course, so if you wanted to make this object immutable, you can use object.freeze, for example, right? And you can freeze this object, right? But that's a different thing. But of course that the const in JavaScript is a const like in any other language. If I say 2, I cannot reassign this to anything else, right? So that's the difference, right? Okay, so let's keep learning. Unlike other languages like C, Java, or JavaScript, there are no parentheses surrounding the 3 components of the for loop. So what they're saying, hey, in Go, this doesn't exist. There's no loop like this. So it's kind of naked, right? So let's try to decipher the difference between what we know and what we are learning. So we're not learning the new thing, we're learning the differences so we can memorize them easier when approaching a new language. So what it is that we actually have to learn from this lesson? Almost nothing, really. So there's no parentheses relative to JavaScript. We can use a shorthand operator here to declare a variable, so we don't have to say var I is equal to 0, right? Var I int is equal to 0, right? So that is the difference. So we can just say this, and that's really the difference. And also it's block scoped, the same thing as is in JavaScript if we're using let. If we're using var, as we saw in JavaScript, if we write a for loop using a var, then that variable is going to leak outside of the loop. So that is the difference, right? The init and post statements are optional. So basically they're saying, hey, you can very easily make this do while or while statement, right? So they're saying, hey, you can in fact omit both initialization. You can just omit it like this and only have the expression, right? Now, as you can see, this is now almost a while loop, right? Right, so you can see for this, sum is less than this, right? So this is basically making a for loop working as a different type of loop, right? All right, great. So let's keep on going. For is go is a while, yes. So that's pretty much what I almost said now. So you can see at the point you can drop the semicolon, see while is spelled for in Go. So this is basically now, as you can see, a while loop, basically, right? Yeah, the stream is going to be on YouTube. I'm streaming to YouTube as well. I'm not a Go expert, but I've been writing Go for some time. But I'm not an expert, by far from that, far from that. At the point you can drop this, so you can see if you want a while loop, so if you don't want to have an expression and an initializer, so you just want to say for sum is less than this, then you can handle when this expression ends, right? So as you can see, you are now responsible. As you can see actually if we run this, right, logically, that we're gonna get 1024, right? So let's go on. If you omit the loop condition, it loops forever, so an infinite loop is compactly expressed. So I guess if you're building a video game, this would be a use case where, you know, when you're building a video game, you have that main loop that's an infinite loop, right? So this is not a very common case that you use, that you write code like this, right? Yeah, for sure we're going to be writing some APIs in Go, absolutely. And I think I need to change my stream a little bit. I need to mix and match it. So I think for the next couple of, maybe a month or two, I'm going to focus more on building my programmer network off stream, some things. And then for when it comes to the streams, we're going to mix and match it a bit, introduce new things, because past couple of streams when it comes to programmer network, I didn't really enjoy coding on stream because we need to find the balance. All right, so if statements. Go if statements are like for loops. The expression needs to not be surrounded by parentheses, but the braces are required. So Go does have pointers, yes. Okay, so let's talk about this. So again, as always, as we've been so far in today's stream, let's focus on things which are different. This way we can let's focus on things which are similar to things we know, and then try to remember the difference, right? So as we read here, this is exactly the same like in JavaScript, but what is the difference? There are no parentheses around it, right? So as you can see, the only difference, let's try to memorize things by, again, using the existing knowledge we have. So if x is greater than 0, as you can see, the only difference is there are no parentheses around this expression. So that's really the only difference, right? All right, let's go next. If with a short statement, like for, the if statement can start with a short statement to execute before the condition. Variables declared by the statement are only in scope until the end of the if. So let's decipher this. So so you can see what we're doing here. This is a little bit, so when I saw this for the first time, it was a little bit confusing, I must admit. So what is this? As you can see, it says, like for, the if statements can start with a short statement to execute before the condition. Do I like this syntax? No. I don't think you learn to, yeah, actually you can see, and this is, you see the last comment in the stream is really the essence of programming. You can see that your opinion and my opinion are completely opposite, because again, this is slightly implicit for me, right? Because again, I would expect this to be simpler. So here we're mixing up two different things. You have an if statement and then you have an expression, right? It is absolutely, Tara. I'm with you, right? It's just, it's not a very, so the reason why I find it strange is because it's not a very common thing to see across different types of languages and paradigms, right? And that makes it, when you come as a new to the language and you look at this, you're like, you're wondering, you know, why? But it is true that as Stara pointed out, it is indeed nice for error handling, right? So what is happening here, right? As it says, right? No, so basically we declare, so we call an expression here, which gets assigned to the variable v, and then we do an if statement, right? As you can see what it says here, which is also very nice, it says variables declared by the, so let's break this down. So what this is basically doing, right? It would be the same as you said v, and then we get it's so hard to copy from here. So it's the same if you did this. Well, it's not the same, but you would get almost, right? Right? So now the difference here, the difference here is pretty huge, right? Because as you can see what it says here, the difference is that if you would do it this way, now this v is in fact declared in a function scope. And that makes it a little bit annoying. You can see that this could become slightly annoying now, right? So there is in fact a significant difference. But if this was really just a single if statement like this, then the difference would be a little bit smaller, right? So yeah, so here it's not really just an if statement. Let me just read the comments. So are we going to use, I don't think that we're going to be using any frameworks. I think that Go itself has a beautiful HTTP library. I think that Go on its own, I think, is a beautiful language, and it's not that I don't want to do it explicitly. We're going to use anything that makes sense, that's logically correct, that makes us more effective, more. I just think that Go has a beautiful standard library, just like C++ has, right? So I think for the most part, we don't really need. One thing that I miss in Go, enums. Yeah. I think we are using Chi at Dream Data where I work, and I know that our infrastructure developers are very happy with it. Yes. No, so in this context here, Leo, the V is only accessible inside of the if statement scope. And that is the fundamental and huge difference, right? All right, so if we run this, I think I broke the code. So let's run it again. We got 9 and 20. Should we look at this together? I don't care. All right, if and else. We're not going to spend too much time here. Same like in JavaScript, same like in C, same in like many languages. If something else, nothing really new here. Simple, right? Now we get into exercises. Should we do these? We probably should. Let's see what they are. Loops and functions. As a way to play with functions and loops, let's implement a square root function. Given a number x, we want to find the number z, for which z or z square is most nearly x. Computers typically compute the square root of x using a loop, starting with some guess z, right? I don't think that we have too much time for this, so I highly advise, if you're going to follow this series, that you kind of go and do this, because I want us to kind of move a little bit faster, right? So those exercises, I'm not quite sure if we should do. How long have I been streaming? Because I want to stay on kind of track. Where can I see that? I've been streaming for 1.5 hours, and how much did I want to devote for this stream? 3 hours. Yeah, working with standard library, basic syntax, basic function declaration, usage, using error handling, basics, error. Okay, so let's just let's skip on this. I don't think I have the time for this. Switch statement. Let's see how it works. Let's kind of just move it to our Go file here, so we can read it a little bit easier. So how is the switch statement in JavaScript? In JavaScript, you say switch. You have the parentheses. You have some variable. Let's say type. This is Java. Let's say type is whatever, I don't know, cool. And then you have cases. You say case, cool, return or do something, do some expression, right? Let's see how it's in Go. It's almost the same, slightly bit different. So if we go back here, a switch statement in Go is a shorter way to write if-else statements. It runs the first case whose value is equal to the condition. Go switch is like the one in C, C++, Java, JavaScript, and PHP, except the only Go runs in the selected case, not all the cases that follow. So what does this mean? This means that, for example, in JavaScript, if you don't return from the case, it's going to propagate, it's going to fall, it's going to drill through, right? Through that. In effect, the break statement that is needed in the end of each case in those languages is provided automatically in Go. So in simple words, if we actually take a look at this, in Go, you don't need to provide return or break statement as you would in JavaScript or C and some other languages, right? So this break, as they claim, is is you can see that, yeah, it's implicitly inserts this. So that is the difference with JavaScript, and that is the difference between, yeah. I think one also difference here that we can see is, I don't know if they have it here. So you can see one fundamental difference in Go and let's say JavaScript is that both, just like with the if statement, you can see here that you can actually declare a variable. Like we have OS, so we basically get the variable OS from the runtime. So this could be an environmental variable, this could be really anything, and then we do the switch on the OS itself. So you see, this is the difference between, let's say, JavaScript, where in JavaScript you can't really do this. You have a case, and you can pass that variable to a function or whatever, but in this case here we can do it inline, right? Exactly. So you can see this is the same like the if statement that we just saw, right? So that is the difference. So nothing to look at here a lot. This works exactly the same like in all other languages that I at least wrote. Cases are evaluated top down, so this one, then this one, etc., etc. Let's see if they were example, right? So if I was 0 in this case, then we will never get to this point, right? Let's see. Another difference, right, is, as you can see, difference from JavaScript, I think. You can also have expressions in the case clauses. So basically what I'm saying, if we write a JavaScript JavaScript switch statement, so if I say here number, we say case 2, let's try to do something here. How do I go back? Yeah. Give me a second. Let me just clear this up. So if we come here, so actually I've never done this in JavaScript, which is completely ironic. But what I'm trying to do here, let's actually try to do something like this. Let's say const b is this. But actually, I have to pull this back. You can, in fact, do this in JavaScript. Super funny. I've never done this in JavaScript for a decade and a half. I didn't even know you can do it up until this point. So I actually learned something new in JavaScript as well. So actually, it wasn't clear to me that you can actually use an expression inside a case. So you can see my case here isn't a primitive value of any sort. It's the function b that returns number 2. So that also seems to be the same in Go as well, right? So if we go back here, you can see that in fact you can do the same in Go, right? So this is kind of, so far there's nothing really different. So far it's the same. Switch with no condition. Again, just going back to this, just because you can do this, would I suggest it? Probably not. Are there some code generation things that you could use this for? Are there ways to write the code to utilize this feature? Absolutely. How readable it is questionable. I need to process this in my mind. Looking at this right now, this would not be maybe explicit enough, because I don't know what the side effect of this could be, right? But technically, yeah, you could write a whole switch statement if you needed to execute. If you want to execute certain functions based on some condition, you can do that instead of saying if whatever, or execute, b, if whatever c, right? So you could in fact write it like this, but should you do it? That's questionable. It's up to you to decide, right? All right, switch without a condition is the same as switch true. So essentially what they're saying is doesn't matter if you omit the case for the switch statement or you pass true, they're both the same. So essentially here you can see switch, so and then they omit the construct, right? And essentially you can see that the value of this thing, right, is not using the if statement, right? So when would you do this, right? When would you do something like this? You would do something like this if you have more structured way to ask certain questions, right? So in this context, right, you could obviously rewrite this. So this is a shorthand of writing. So you would really use this to not use the if statement, if I may. There's really no other reason so far, I have to say, right? Because this is like if, else if, and then this is a default else, right? So this is a way to maybe save some characters and not be like, if t dot hour is, less than 12. So you can see it's almost the same. It does the same thing so far, but it's just a different syntax. So should you do this? Depends on your style, depends what you like, because styles are very relative in programming. Something that I might like, you might really hate a lot. So it's up to you to decide. And now we're getting into interesting things, into things which we have in JavaScript as well, especially during Angular JS 1 days. We used, even with jQuery, we used defer, right? I remember from a very, very long ago, we've been using deferred in jQuery and stuff like that. But this was a little bit different. This is something a little bit different, right? So let's get into this. The first statement defers the execution of a function until the surrounding function returns. And this is going to be a little bit shocking feature for people who coming from the different languages. So the deferred calls, the JavaScript doesn't have anything like this. The deferred call arguments are evaluated immediately, but the function call is not executed. jQuery is probably still one of the most used JavaScript libraries out there. jQuery usage graph. I think people underestimate because of if you haven't watched, guys, I recorded a YouTube video recently called influencer driven development. You should really watch it. I will share it with you, so I highly advise you to watch this video, because a lot of you are influenced by Twitter heroes, as I call them, YouTube heroes and stuff like that. jQuery is a very, very, very used library. Just because you hear some asshole on YouTube telling you that if you're using something that hasn't been released 3 seconds ago isn't cool, you can neglect all of that propaganda. I call it programming propaganda, right? jQuery is a library, is a part of almost any modern library. jQuery still works in every browser. It has polyfills, etc., etc., etc. So if this graph doesn't tell you why I recorded this video that I just shared with you, nothing will. So jQuery is a valid library. It's a library that still works. It's just plain JavaScript, just slightly bit improved with some polyfills, so it works across the browsers, but fundamentally it's just improved DOM API. So DOM API, Document Object Model API, is a little bit verbose and primitive. So jQuery just improves that slightly bit to give you the edge, right? So in a plain DOM API, you have to do things like document dot, get, get elements by ID, whatever, right? jQuery improves that slightly bit and some other things, but it's a great library still. If you're building a simple website, jQuery is still a great thing to use. It's a super nice library. Anyway, that's a different subject. So defer, what does the defer do? The deferred calls arguments are evaluated immediately, meaning the arguments are going to get evaluated, but the function is going to execute it once the surrounding function returns, meaning when the main returns, this is going to run. We're going to get into when do you want to use this. Let me just read the statement. I'm a Fullbringer. Had to build my own rich text editor for work this week because they refused to pay 80 quid for one, which are... Fullbringer, don't do that to yourself, man. I get you. Don't go that path. You're gonna cry. You're gonna cry blood. There's nothing harder in web development than building a working rich text editor. That's the top-notch challenge of front-end development. Don't you dare to do that to yourself. I'm not saying to your company. I'm using TipTap.js. I used to use JavaJS until assholes at Facebook decided to deprecate it. This is currently the shit, if I may. Again, there is no golden bullet. There's no silver bullet, right? So there's no silver bullet. No matter what you use, you will fail, right? Rich text editing is hard. You're lucky if you just need basic functionality like headings, bold, italic, this Word document type of stuff. Once you, as for programmer network as I have, once you start building custom rich text editing capabilities, then you go into Prose Mirror API, and this is a huge API that you have to learn. So once you have the competence, it becomes easy, as with everything else. That's why I say never shit on things, because most likely you're shitting on them because you have no enough knowledge about them. If you shit about PHP or anything else, you probably suck at that, right? In 99% of cases. So the reason why I'm saying you're gonna cry blood is because this is a fundamentally hard thing to do properly. It's very complex. If you end up using TipTap.js as we are, and you need to build custom features for it, you will need to familiarize yourself with a Prose Mirror API, because TipTap.js is built on top of this framework. This is a tool, a framework, a context on which many rich text editors are built, right? And I'm gonna answer the questions on YouTube. Just give me a second. So seriously, don't build your own rich text editor. That's a huge challenge you're gonna set yourself for, and it's not gonna end well. It's not gonna end well. Hey, let me just read the YouTube comment. Hey, just stumbled upon your channel. Don't know much about Go, but want to ask any ideas for web dev side projects or nice idea for my capstone. I currently know HTML. Nobody can tell you. Nobody can give you an advice on side projects, man. You have to ask yourself, where's your passion? What do you like? Do you like music, video games, guitars? You know, dildos, whatever it is. And then wherever your passion leads, you build a project. I mean, it doesn't really matter, right? Like, you can either build something you like, or you can build something random. If you're going to build something that's random, then it doesn't really matter what you're going to build. Build a to-do app or a clone of some shit. I can see that a lot of juniors today, they're building clones of certain things and stuff like that. So maybe you can, yeah. Anyway, let's go back to this. Stacking deferred functions calls are pushed onto a stack. When a function returns, its deferred calls are executed in last in first order. So basically LIFO, right? To learn more about deferred statements, read this blog. Okay, so last in first out. So basically, as they're saying, if we are to grab this thing, the defer statement is a little bit, I wouldn't say complicated, but a little bit. You need to have a use case. When do you want to use this? So we're going to talk about that. But let's just see what they wrote here. So it's very important. So deferred function calls are pushed onto the stack, right? When a function returns, its deferred calls are executed in the last in, first out order, right? So the function that gets executed last is clean from the stack. So it's LIFO basically, right? To learn more about the first statements, read the blog post. We will not do that. We'll skip it on this one because we need a use case. So now I just want to make a point while we're here. I want to make a point that's way more important than the defer. So we are now at the point of reading something that we can't contextualize or apply in our heads, especially if you haven't used this keyword, which is in this case specific to Go, at least on how it works. At this point, this is where bottom-up approach of learning kind of sucks, right? Because so far in this documentation, what they haven't told us, the most important detail, is why does this exist? Where is this used? Where is this deferred statement used? You can, of course, now make some assumptions where this could potentially be useful. But if you're ever writing a new language, new documentation, new anything, always start with a use case. Because this statement, we know what we have learned so far about it. The first statement is that it gets executed once the enclosing function returns. And that's a cool story. That's a beautiful story. But what we haven't learned is that, hey, where did this keyword find place in a Go community? Where are people using this thing, right? So that is the, if they have started with this, and maybe let me just make sure that I don't no, so they haven't. So this is the problem. So you're probably now past 10 minutes while we're reading this, you're thinking, okay, that's cool, but where the hell, why would I want to do this? Why would I want to have a function expression here, function invocation like print line, and then why would I put this here and then wait for this? Why don't I just, put this somewhere in the bottom, right? But then that wouldn't be the same. Well, it wouldn't matter because again, this is going to execute when the function executes, right? So let's see if they, so they haven't really expressed when is it going to use. But let's try to follow the official documentation. Maybe we're going to get to that point. So now we're getting into a land where an average developer coming from dynamically typed languages will get a little bit confused, because now we're getting into pointers, we're getting into sort of dereferencing, indirections, and stuff like that. So this is a little bit dangerous place now, right? Because an average dynamically typed engineer is not familiar with these concepts. Why is that the case? Because of garbage collector, because of the tooling that really does this for you. Your tooling allocates memory for you, deallocates it, etc., etc. So you're kind of free from this. You don't have to think about passing a pointer, passing a copy of the value, right, etc., etc. But we're doing that in JavaScript already. So before we can go into pointers, let's talk about JavaScript, right? Because we can then reference it. So let's imagine that in JavaScript we have a foo. So let's actually start with JavaScript. I can explain pointers through JavaScript a little bit, not fully, but a little bit, because we don't have the constructs, we don't have the keywords to fully explain it. Let's imagine in JavaScript that you have something called change user. You have a function, and this function takes a user object, right? And then it updates the user's name. It updates the user. So it says user.name. It's going to be a very, Jesus Christ, man, this is so annoying. It's going to be a very arbitrary function, but I'm going to try to illustrate the point of this, right? And then this name is going to be whatever this name is, right? And then we can have some user here. So we're going to say, I'm going to use var just so we can override this here in the console. So I'm going to say var name is John Doe. And then I'm going to call this function change user, right? But actually, that's not what I want. I'm just going to say here, actually, I'm going to say var user. And then here I'm going to say name is John Doe. And I'm going to call this function. I'm going to pass it my user that I just defined here. And I'm going to say the new name is going to be Don Joe. And then now if I print the user is going to be Don Joe, right? What have we done here? So now we have basically mutated the original object. How did this happen? Well, we have passed a reference to this object, right? And then we have updated the object itself. So here we're passing a pointer. This user that we're passing actually in JavaScript, we're not passing we're passing a pointer. So you're gonna usually in JavaScript hear concepts such as, is this mutable? Is it immutable, right? What does these concepts mean? Usually when we talk about these things, we're thinking about, hey, when this function gets some object, for example, in this case, does that function mutate that object or does it return a new object, right? So immutability is a huge concept in web development because we try, in functional programming as well, because we try to keep original objects or values that we operate on immutable. We don't want to change this. So in this context, I have actually mutated the original user. Why is this bad? Like, why is this often very, very, very difficult, right? Why is this software written like this difficult often to read, right? So let's imagine that in this little program we have here, we had 20 other functions that were operating on this user structure, on this user, right? And let's imagine that each one of these 20 functions were mutating this original user, right? It would be very difficult in your program, when your program breaks, and software breaks every single day for all of us, it would be very difficult for you to decipher at which point has this user changed, which function did it, and why it broke, right? So what we decided in the development community is that whenever we get a user like this, we actually don't mutate the original value, but we say return, and then we usually we use the spread operator. Before we used to use object assign, right? So we either do this, and then we say a name, right? You know, before we had an object with a spread operator in JavaScript, we would do, you know, object assign. So object assign, so we would do a return object dot assign, right? And then we would pass the target, so we would pass the user. And then here we would say merge with an object called name, right? But these are the constraints. This is JavaScript now. Just talking about how the JavaScript works, right? So now if I pass this user, which is really a pointer, we're not really mutating the user. We're returning the new user, right? So if we would rewrite the function, this function here, and we have by accident removed that extra dot we need in there, right? So let's put it back here. So you can see now that the original user is still John Doe. So we haven't really mutated the original user, which is this one. So we have changed the user, but we have returned a new user from this function. So why am I even talking about this in the context of pointers, right? Exactly because of that. So in certain times when you're running your functions, there are certain times when you want to have a reference to some value in memory, and you want to change that value in memory, and sometimes you want to pass value to a function and then compute and then return something from that function and then use that computed value. So in simple words, we have pointers because sometimes we want to point to the values in memory so we can mutate them, and sometimes we don't want to do that. Now, this immutability discussion that I just spoke about is irrelevant in the context of talking about the pointers, because this is a different, right? It's a different discussion. Why you want to be immutable or not immutable, that's a different discussion. But I just wanted to kind of get you close to this concept of immutability because it's a very big subject in the JavaScript world, right? So now we know that we can pass values by reference or by value. Actually, if I go to Google Images, right, there's that very iconic image, pass by reference and value. There's this coffee cup I remember, and this is the best illustrator of when you're learning pointers, right? If we take a look at this, right, this is a pass by reference, right? So observe what's happening. When you pass by reference, you can see this cup is a variable. Imagine this is var cup is some object. You can see that the original value is changing. When you pass by value, the original value is not changing. We're going to return the new value from this function. So when you pass a pointer, a reference, you're going to change the original value. When you don't pass a pointer, you're not going to do that. So in JavaScript, we don't have so when we are passing an object in JavaScript, we unfortunately don't have the capability to pass object as a value. So that's why in your return statements, you're saying, no, I don't want to mutate this thing that I'm passing to this function, so just return, make a copy of this, what I'm passing, and then update certain thing inside of that object. So that's the difference. So we are using pointers in JavaScript, right? But we don't have the language keywords or language syntax to say, I actually don't want to pass this person as a pointer. I want to pass this person as a value. We don't have that capability in JavaScript. So we have to make these object copies and then return them. In languages like Go, you can in fact say, hey, well, this is an object, this is a struct, But I want to pass this as a value, not as an actual reference, right? So that is the difference, right? And let me just read the question. I never understood really why are people so pro immutability. Nobody seems to care about the fact that we're creating new objects in memory for each thing we do with the object. I think Nurko, I think you're right to a huge degree. So I think this is the danger in Nurko of being the programming absolutist, right? I think you are 100% right, and you're also 100% wrong at the same time, and that's kind of irony, isn't it? But why am I saying this? I think most developers, or many developers, if I may say, don't understand that we have long ago moved away from efficient software, right? So software today isn't built for performance. Software today is built for quick releases, high productivity, and it's completely product customer oriented and driven. Most software we build today actually is really bad, right? Why? Because your computer has probably 32 gigs of RAM, your phone has 8 gigs of RAM. So community of programming has moved from floppy disk to buy more RAM. Exactly, right? So we can be absolutists. We can pretend that, oh, I should use this data type here, whatever, because I'm gonna save some. And you're right. That's why I say you're 100% right. But the place where you're wrong is that somebody cares. Nobody cares. I mean, you have a bunch of idiots every year standing in rows to get a new iPhone because it's 3% more rounded, right? So like you cannot underestimate the average IQ of a consumer, right? Which is pretty low. You have people who have iPhone 14 or 15 and next year they're going to buy 16 because it's more rounded. So we have moved away from going to the moon with a floppy disk to really nobody cares about memory, right? So of course you as a developer, you care, I care, but your product manager doesn't care. Your CTO doesn't care. What your product manager cares about is absolutely. Don't take me wrong. Look, if you're a embedded developer, you have a PCB that has half gigs of RAM. You have no choice. But that's a different type of job. So if you are an embedded developer doing some IoT stuff, you're super constrained by resources. If you have some 8-bit CPU or whatever, but that's a huge edge case. If we are talking about web apps, I mean, look, you don't have to agree with me. Open your task manager now on your Windows, Linux, Mac OS and see how much memory is your browser using. The same Google, the same company that molests you when you go to take an interview with them, just look how inefficient their software is. Open your Chrome now. And how much memory is it using? 2 gigs, 3 gigs of memory, right? So we can agree or disagree, that's irrelevant. But if you are realistic, just open the tool that you're using now on your computer and see how inefficient everything is. This is not a matter of opinion. This is a factual thing. Open the tools you're using now and boom. So you get what I mean? So this is not a matter of me having some distorted, unrealistic opinion for the sake of having it. When I open my, activity manager on my Mac or here, I mean, what the hell? My Windows now is using probably 12, 15 gigs of RAM for what? I have VS Code opened, OBS, and the browser, right? So the point is, right, is like that gives you a clear indication that software is no longer built for performance. It's built for quick releases, consumers. And of course, this is not to say that it's that this is mutually exclusive. Our job is to give our best to do that, to build efficient software. I'm just saying the emphasis is no longer on that, right? There you go, IntelliJ 8 gigs. Your fucking code editor is using 8 gigs of RAM, right? It's like you're developing, a whole galaxy in 3D, right? So what are we talking about? And then when you apply to IntelliJ as a developer, oh, let's see how's your knowledge in DSA. Like, dude, your fucking editor that you're selling takes 8 gigs of RAM, man, right? So No, but that's exactly the point. Look, I think we're in the same page 100%. That's the whole point. Hardware has gotten so cheap that logically community has moved from caring about declaring that variable in the most efficient way to not just caring. It's like, who cares, man? The user has 600 gigs of RAM, right? Is that wrong? It is. Does that change the fact that that's the reality? It doesn't, right? That's just how it is. And yeah. All right. Cool. Okay, let's continue with our Go thing. So pointers, right? So we just started this, right? Go has pointer. A pointer holds the memory address of a value. So this is really what a pointer is. Pointer holds the memory address of a value. So you have some memory, and this memory is separated in blocks like this. And the pointer that you define, you have some pointer. This pointer points to the memory address of that variable, right? So it's like, hey, your value is in this block of memory. That's really all that there is. So I have a variable of type pointer, and that pointer points to a block of memory somewhere on your heap or whatever, right? All right, so how do we declare a pointer? Again, just a variable that holds the address of a value in memory. It's the same you do in C++, in many other languages. The type t is a pointer to a t value. Its zero value is nil. If you don't assign, so you can see that the default value of a pointer is nil, meaning it's pointing to nothing. Very logical. It's like a visit card that does not hold the person but the address. It's a good one, yeah. The ampersand operator generates a pointer to its operand. We're gonna see now this on examples. The asterisk operator denotes the pointer's underlying value. So we're gonna have to, unlike C, Go has no pointer arithmetic, so we're also gonna skip that. Okay. So if you run this thing, so let's go through this code. I think this is now where some of you, if you want to continue, we're going to have next 3 streams, we're going to be learning Go, and then we're going to be building things in Go. We need to make sure that after I finish with the stream today, please go to these things if you want to follow up in the next stream. Otherwise, if you don't follow this, do all null values point to the same null value? That's a good question. I actually don't know. If somebody knows, I'm sure that there are people here who know Go way better than me. I don't actually know, to be honest. And thank you everybody for your follows. Okay, let's read this code a little bit here, right? So we use the short operand, right? Let's actually move this to main Go just so we can read it a little bit better. So actually let's also get the because I can't run this yet. Because Go is a beautiful language. Go is my favorite language. It's a beautiful language, and if I would be learning programming again from scratch, Go would probably be the first language I would learn. It's a beautiful language for the most part. All right, so I and J. So we define 2 values. I'm just reading the chat, I'm sorry. We're using Go at work already. It's just I wanted to record some YouTube videos on Go, and I figured instead of doing that in isolation, sitting on my own in the room, I'm gonna do 4 streams, and in those 4 streams we're gonna learn Go together, and then this is gonna. I did code in C++ 15 years ago, yes. C# I've coded, but not professionally, so I have. Yeah, and I love C#. It's a beautiful language. C++ and Go have very little overlap. What you build in Go and what you build in C++ is slightly different, right? Functional languages. I love Haskell. Haskell is a nice language. I wrote some Haskell also, not professionally, just for fun myself. I'm just reading the questions before if you need performance, nil is a Pre-declared identifier representing the 0 value for pointer channel function interface map. Okay, got it. Absolutely, Max, please do. Chillax, we hired 2 developers 6 months ago. 2 Go developers, Guga from Brazil and Victor from Sweden. So I think for now we're full, but we might need, I mean, just stick around. I don't know, I need to ask. It's holiday time now. I don't think that we're hiring and people at all right now, because we recently hired like 5. Nurko, that's fair enough, man. As I always say, the best language in the world is the one that you know best and the one that works best for you. So I always say I would never learn something for the sake of just learning it. Of course, you know, I think we should be learning new things for fun and to evolve as professionals, to get new ideas so we can apply them, you know, into our ecosystem where we work. But you should never just learn a language for the sake of being brute forced or influenced by the YouTube gods, Twitter gods and stuff, right? Yeah, absolutely, please do. So I think yeah. Let's just answer a few questions and then we continue. So let me just read them. Based on what you decide to do, think on JS or Golang company. So JavaScript is a very different ecosystem. So people have to understand one fundamental thing. So when it comes to building products, right? Nothing beats JavaScript. That is the fundamental and objective truth. When it comes to building products fast, when it comes to building products with minimal amount of people, when it comes to building products and hiring people easily, nothing beats JavaScript. So not even, okay, well, you don't, okay, let's get to Python. So look, let's just break this down just for people. So JavaScript is a language of startups, right? So JavaScript is a great language when you have minimal amount of money, minimal amount of people, and you want to hire very fast. Hiring, when you're making technical decisions as a founder, one of the core decisions that you have to make is, I choose a stack. How easily can I hire people for this stack? If you decide to write Haskell and you're a startup of 2 people, you have to ask yourself, how quickly can I find 1 out of 17 Haskell developers which are still alive, and how many billions they're going to cost per second, right? Whereas you go on the street and you find a JavaScript developer whipping his ass, right? So the point is, when you're making technical decision as experienced, reasonable leader, manager, founder, performance is not even in most cases something you think about. Nobody chooses JavaScript for performance, but no product when it's released needs to scale to billion people. So when if you ever open your own company and you want to ship fast and fail fast, you go with JavaScript because of huge ecosystem, easy to hire, easy to find help, easy to outsource, etc. Once you succeed, if ever, because 70 to 80% of companies actually fail before they even get to a next point, then you can narrow down certain subsystems of your core system and you improve them, right? So why choose JavaScript or Go, whatever? There are certain stages in your company, in product development, when you can choose X over Y. But if you're a startup, and if you're building a web application, some portal that you're selling, JavaScript is the absolute king. And this is not a matter of opinion. This is the matter of statistics. If you take a look at the most popular languages, you're going to see exactly what I'm saying. This is not my opinion that I formed out of my asshole. This is a statistical fact that you can find. That's why dynamic languages are so popular, not because they're performant, it's because you can build things quickly with them. You have no types, your software is going to fail, but what is the value of building fast versus failing sometimes? because all the software fails, strictly or dynamically written. It's just you have to figure out the value of it. Do we care if we fail a little bit more for the value of just printing that code fast? Most people do, right? So the thing is, this is where many developers, especially junior ones, when you're a junior developer, you learn some code, you feel like you're on top of the world. You think you're smart, you're writing some code. But as you grow as a software engineer, you start realizing that the most important things in business are not code related. They're related to so many effects around it. Again, as I said, hiring, expanding the teams, finding help online, finding existing libraries, etc., etc. So for example, languages like Rust, languages like Zig, and all of this new shit, it's irrelevant that they're performant in this or that way. What most businesses care about is like, is this language going to be alive in 5 years? And how well established the ecosystem is. No reasonable founder is going to pick a language where you have to re-implement authentication. No reasonable founder is going to pick a language where you can't find a library to do basic things. So this is the business world, not some fairyland, sweaty nerd, basement dweller dream about, oh, I wrote this for loop, it runs in 2 microseconds. Who gives a fuck, dude? Like, nobody gives a shit about that. We just spoke that your fucking computer has 40 gigs of RAM for a reason, right? Oh, I wrote this function that executes so fast, and like, shut the fuck up, man. Like, who gives a fuck about that? Only you, bro. Nobody else, right? So it's like, you know, like, grow up, right? Like, no customer is going to pay for your fucking software because that sum function executed in 3 microseconds, right? You get what I mean? So it's ridiculous, man. Some people are just like either like 14 years old or just plain fucking dumb, man. Business needs to generate features, be competitive on the market, and it needs to generate money so it can pay your fucking shitty salary that you want to grow every 6 months. I'm a software engineer, my salary didn't grow for 3 days, this is not gonna work out. This is like, dude, come on, man. Like, you have to provide value constantly, right? So that's how it works, right? Oh, I wrote this Rust function, man. You so fast. Oh man, like I run this program on my computer. Oh, so very good. Oh, it's a very strong function. Very like very full of meat. Very like, come on, man. Yeah, it's a very safe language. When I run this function, man, not even a granada would kill it, right? It's so strong. Like, I literally put my computer on fire, but then, you know, like, it didn't burn because Rust is so strong and you know, it was putting the fire out. Come on, man. All right, let's go. Rust plus Vim. Yeah. Okay, anyway, let's go back. I'm triggering myself too much. I need to slap myself in the face. Wait. I unit tested this function so much that I didn't have enough of memory to run it because there's so many tests to run. And yeah, so at work we use Go for all the infrastructure. Because at Dream Data, where I work, we're a GCP partner. Like, our whole infrastructure is on GCP. Like, we're using Kubernetes and BigQuery, Vertex AI, and a lot of other things, right? Yeah. All right. So let's go on, right? So when it comes to as a junior, I mean, in my opinion, as any sort of developer, you should be joining startups. Startups are amazing. I've been working for startups for 16 years almost now, and I could not imagine myself not working for one. All right, guys. So because I want to kind of round up this stream soon, let's maybe not start with pointers now. Okay, so let's continue in the next. Okay, so I'm not rounding up the stream now, I mean, but let's kind of recap what we've learned so far, right? So it's Nightwish, yes. So let's actually see. Let's just make sure. Give me a second. Give me just 2 seconds. All right. So okay. Let's just recap, and then let's have some chats about programming in general. So what have we learned so far in this stream, right? Because I want to do 4 streams around 3-4 hours each, where we try to learn Go together. This is all going to be recorded on YouTube once I stop the stream. Yeah, please add me to LinkedIn, man. I mean, I love when people find me through this stream because I love to have fellow developers on LinkedIn, of course. So listen, so what have we learned so far about Go, right? So let's just recap very quickly. So we learned that every Go program needs to have a package main, like in many other languages, like we said in C, in C++, in many languages, there's a central, in nodejs as well, there's always a centralized point for the program to run. And that package then calls other core functions, etc., etc. You can add me to anything, man, of course. Then we learned that we import packages using an import keyword, again, as in many other languages. And then we learned again that there's a function main, and then in this function main we call things. We learned basic things. We learned how do we declare variables by using a var keyword outside of the function scope. We learned about some implicit conversion that Go does. Then we compared it to a JavaScript coercion, and then I showed you how the coercion works in JavaScript relative to this. We learned here that that variables that we declared with a certain type are given default values. So if we say var name string, we learned that the default value of certain variables are going to get default value. So if you declare a variable and you give it a string, it's implicitly given an empty string. If we define a number, if we say var number int, this is going to be a 0. Boolean is going to be false, etc., etc. So this is common constraints, common features of most languages. Some languages do this or that. I then mentioned that in JavaScript, if you declare a variable and you don't give it a value, it gets implicit undefined. So if you remember in JavaScript, if you say, I don't know, let x like this, it's going to be undefined by default, right? So we learned all of these things. Then we learned some differences. We learned how do you export things in Go versus, let's say, Node.js, JavaScript, Python, etc. And then we learned some things that we didn't really like. So for example, in Python, in Go, if you want to export a function, aka a method, from a package, you give it a capital name. So you can see here fmt print line, this p is capitalized, not randomly. Like for example, in JavaScript, generally if you see a capital letter anywhere, that usually indicates that something is a constructor. So for example, in JavaScript, if you say new error, this E is capital because that means this is a class, it's a constructor, it's a right. In Go, that's not the case. In Go, if you see a variable starting with a capital letter, that means it's exported, it's global, other packages can import it. If this P was lowercase, then it would be a private member under quotes of that module versus package. Then we said that package is basically a module. Those two things are kind of intertwined. They're used in different languages, but they represent, in most cases, the same thing. A package is a module. It's a box of things which usually solve similar problem, and then it's exported. As you can see in this context, we have format fmt, and this fmt has bunch of similar methods for printing things. So in JavaScript, this would be a console constructor, like console, right? In Golang is fmt, right? Then we learned that Go has types, but then we realized that every language has types. In Go, you have unsigned and signed integers, etc., etc., floating point numbers, strings, booleans, etc. Structs, we didn't speak about structs yet. We're gonna do that probably next time. But the point is, every language has this, so there's nothing new in there. For the most part, when you're working with numbers, you're gonna be using, for example, int. Are there gonna be instances in which you will want to define a certain size of that number? Probably. Is that gonna happen when you're building an API? Probably not, because when we start building an API in Go, we're gonna be doing basically the same stuff we're doing in our Fastify API in Programmer Network. We're gonna be interfacing with some databases. We're gonna be calling some services, and we're gonna be working with quite a user-friendly data, which is a number might be how old you are or whatever. So it's gonna be very small integers. Then we learned about variable declaration. We said this, but then there was a shorthand. You can say x. There was this shorter way to declare a variable. And then you can see here we didn't provide a type because, again, as I said, Go is going to infer the type from the value. This is a common thing you're going to see in TypeScript. In TypeScript, you can say something like, const x is 5, or you can say const x number is 5, right? So in many languages, you have this, again, which is questionable. Do I personally like it or not? Because I either like the language to be completely strict and typed, or this is somewhere in between, so I don't really like that, but that's what it is. But anyway, in many languages, including TypeScript, which is a superset, it's not a language, you can do this. So as you can see here, x is going to be inferred. Then we spoke about converting values from one type to another. I showed you in this stream how you do that in JavaScript. In Go is a little bit different. You would say, I think, math, right, dot float or whatever, or square, right? So you would basically, and I think you would actually, give me a second. So if I say float 32, right, you would basically use float, or you would use the int, right? So you would use the int. So you would use the functions which are, so you would need to do explicit conversion. So in JavaScript, you can do explicit, but you can do implicit conversion as well. As I showed you, if we go back here, that's the difference between Go and JavaScript. For example, in JavaScript, you can say 2 plus 2 is going to be 22, because JavaScript interpreter assumed, because of this left-sided value, that you're trying to concatenate two strings. What you could technically do, right, you could use the plus sign here to kind of fake it, to ensure that, hey, to convert this to 2, but you can also do it explicitly. You can say parse int 2 plus 2, right? So in Go, as we just saw, there is no implicit coercion as we have in JavaScript. In Go, you cannot try to subtract two values of different type, because you would get an error. So in Go, you cannot say 2 plus 2. You would have to either convert 2 to a string, or this 2 to a number, depending on what the output is. Maybe you actually want to say, hey, subtract or sum or whatever, two strings, whatever. But anyway, in Go and strictly typed languages like that, it's a lot more sensitive than in Java. In JavaScript, you can do almost whatever you want. I'm Zdran. Good evening, buddy. How are you? We're just learning some Go this stream. Okay, so what else? So if we go back here, then we learned about if statements, right? So we learned that if we say if we have something like this, and then we say if let's say something like this, right? We've learned the difference between Go syntax and JavaScript. In Go, we learned that the only difference here is that there's no parentheses around the expression in Go. In JavaScript, we have them. As you can see, the rest of the stuff looks exactly the same. We learned, let's just quickly summarize all of it. When we were writing functions, we learned that if the function arguments, if you have multiple function arguments and they're of the same type, you are basically, you can put the type last. So if I have function foo and I have x, y, and z, I can say at the end int, and I can say int. I can put the type at the end simply because now this implies that x and y and z are all, or z are all of integer type. That doesn't mean that you can't be explicit. This is what I generally do. I love the explicitness of it. So that's it. Then we've learned that in Go, you can return multiple values from a function. Then we compare that to JavaScript. So in Go, basically, you can do return x, y, and z. So this would literally return let's just say, let's actually do some expression like this. Let's try to do something like this. And then also, like Snail Kitty is saying, indeed, it's true. You don't really have to omit them, right? So you're not gonna get an error, but you will usually see them being omitted, right? What else am I forgetting? What else did we speak about? We spoke about we got to the pointers. So the next stream we're gonna do the pointers, but what else did we speak about? And yeah, indeed, exactly, right? Oops, sorry. And actually, I think now we're returning only the two thing. Oops. Yeah, Go format will exactly. Naked returns. Yeah, so we also spoke about naked returns, right? So we also spoke about naked returns, and yes. So this was the thing that we didn't like, right? So for example, if we do this, and this is a little bit different now because we have a return type defined here, right? But naked returns are one of the features that we didn't like, meaning that if you don't provide the values at the end of your return function, right? We will basically, the function itself is going to return, right? Let's just, so if we do something like this, this function now is going to return x and y. The reason why we all agreed that this is not a great feature is because this doesn't really make sense because it's just unclear. In JavaScript, you would get undefined here, right? In many languages, you would get different behavior. In Go, if you do this, this function indeed will return this, right? And that's not really great. What did I want to do? What else did I want to do? So we discussed for loops and switch statements and all of that stuff, right? So we said we pretty much do the for loop almost the same like in JavaScript. The only difference is that we generally, again, omit these things, right? We discussed about declaring expressions inside of the for and if statements, right? So you can basically, as you can see here, we're just as... So yes, as Snail Kitty is saying, you can declare variables in if, for, and switch scopes. That's, in a way, an interesting feature, right? So you can say basically something like if, right? And then here you can say, you can define basically a variable. You can say var, right? So you can do this. Let's use the ChatGPT just a bit. So you can do things like this, right? This is basically something that you can't do in JavaScript, right? So you can say declare the x that's only going to be accessible in the if statement scope. We can do the same for looping through things, etc., etc. So this is something that's also unique to Go in this context, at least relative to JavaScript. We can use switch statements to kind of not use the if statements like we said, right? Yeah, so you can do this, right? Whatever, right? So this is in a way, this is a way in Go to kind of write an if statement in a kind of nicer way. You can see we also learned, right, that at least for now, we haven't touched base on some other things, but for now, a switch statement in Go doesn't need break statements or returns like you would need in JavaScript. So each one of these cases, if they're evaluated right now, would break automatically. So there's a basically invisible implicit break. There is a filter and stuff, but we haven't spoken about that yet. But keep in mind this switch statement now, if this case would be true, the switch statement would break. So there's a difference between switch statement in Go and switch statement in JavaScript, right? So I think we've covered pretty much all the basic constraints or basic language fundamental fragments of any language, in this case Go, right? So I think so far what I would advise people who will watch this on YouTube and people who will continue, because we're going to have 3 more streams on Go, and then we're going to eventually build something together. We're going to build an actual API. I would advise that you spend an hour or 2 just writing this logic a bit, just so you can memorize it, like just so you can kind of especially things like inline variable declarations, like in the if statements, some looping through and stuff like that. Because even though this is very kind of bottom up for now, it's very beginner type of content, right? It's still the fundamental thing for everything else that's going to come, right? So we need to make sure that we familiarize ourselves with the syntax that we know in other languages relative to this. And then when, I think in maybe already next stream, we're going to be probably going to be building some CLI tool or whatever. But basically, I think we got to the point of pointers here. Let me actually see if this is, yeah. So this is how far we got to this point. So I think in the next stream, we're going to continue with that. So what I advise everybody is that you set up Go on your machine. So install Go, go to the download, install it, install the Go extension for VS Code, so we can continue, because we're going to be using this to build things. And then at the very least, you don't have to necessarily watch the whole thing, but I think it was a very interesting stream. I think it was a combination of a lot of different types of content and knowledge, so I think you should watch it. So we didn't get to this point yet, but we will next time. But as you can see, we have a little, I just asked ChatGPT to generate some, I said it, hey, I want to teach Go, or I want to learn Go in 4 Twitch streams. So break it down, each stream to 3 hours, and I think we are at the mark of 3 hours right now, almost. So we have 30 more minutes, so we're going to spend a little bit more time. But basically, this is the idea. So in 3 maybe or 4 streams, we should be at the point where we actually built a complete application. We're gonna, I'm gonna push that to some GitHub repository so we can all contribute, we can all improve it. So I think it's gonna be a very interesting series of streams, because this time, unlike other streams where I just built Programmer Network in isolation, I think this is gonna be something that we're gonna code together. So, and I'm gonna make mistakes for sure, and there's way better Go developers in this chat than I am, without a single doubt. I can see that already. So maybe some of these people can actually help us out, review our code, maybe give us some suggestions, because the hardest thing when you're switching to a different language isn't the language itself. It's not about learning the syntax. It's about really knowing these tiny points about community. Hey, what is community doing? Which modules is community using? Idiomatic Go. So there's a lot of these things that you can only know by building apps in a certain ecosystem. And I think this is where more experienced Go developers will be able to help us here, is to kind of give us this kind of little things that you learn. You see how, for me, JavaScript, I know almost every detail. I'm an expert in that, right? But in Go, I'm not on that level, because I don't know the low-level constraints of Go as I know, for example, with JavaScript, right? So we hopefully some people are going to be able to help us, those who are more knowledgeable than us, in giving us some tips, right? Yeah, for sure. I did. One of the most, actually, I think the most thumbed up question in Go history was asked by me 5 or 6 years ago, because when Go became kind of mainstream under quotes, it was a lot more strict in its tooling. So for example, when Go was released, when it was open sourced, every single function you wrote had to have a comment on top of it, because Go format, Go lint and stuff was so so hard in these things. And I remember asking, I think this was 6 or 7 years ago, I remember asking, man, what the hell do I do? I don't know how to compile my Go project because it's you know, the tooling is asking me to do something. And I remember I asked it in a little bit ironic and almost a rude way. I need to find that maybe for the next stream. It was quite a hilarious thing. But I remember when Go was released, it was like quite aggressive, on even more aggressive than it is today. So yeah, we can, okay, let me just do one thing. Yeah, for sure. It was quite aggressive. It was quite aggressive. Give me 1 second, background removal. So if I do this and I do this. So yeah, let's, as always at the end of the stream, I would like to see if people have any questions. It doesn't have to be about this session of Go, but we can, let me read the YouTube questions as well. I need to find a better way to read the questions there. Hey, how do you use ChatGPT to learn new tech? Can you suggest me? Just stumble on, yeah. Very interesting. Yeah, so the next 2 or 3 streams are going to be about Go, and then we're going to be definitely building some services for programming networking Go. I'm looking forward to that. So yeah, I mean, please, for those of you, so we only use Chai or Chi at Dream Data as the router, as stuff, but generally, most people that I know who write Go, they don't use any framework. There's Jin, and there are a few things out there that some people use, but I think Go is, as it is a beautiful language. Yeah. Will you start coding Go? I mean, we will definitely be building services in Go for Programmer Network, for sure. For sure. I think we're going to stick to the standard library. I mean, for sure, at least for those next 3 sessions of our stream, we will definitely not be using any framework. There's no question about that. So we'll definitely not be using any framework. So I can tell you that much. Yes, Numinix, absolutely. The Tech Freak. I'm from Denmark, my friend. But look, guys, so listen, I have a lot of very interesting videos on my YouTube that I recently recorded. I genuinely think they're pretty awesome videos, so give them a shot. I'm gonna share it with you now. I've been getting a lot of actually good traffic from them. Let me just actually, I don't even know how to find them. Let me just go and find the playlist. But yeah, I've recorded some quite awesome videos recently that I think you guys could take a look at as well. And I'm just going to share it with you guys. We have a couple of more minutes left. We have 20 more minutes. Let's see if the people... Let's see if there's any APIs in Go will be fun. Yeah, for sure. I mean, APIs in Go are very simple, right? So we're going to be writing probably some sort of a clean architecture, whatever. But so that's the same reason. So believe it or not, APIs written in Go are very similar to the APIs written in Fastify, written in Express.js even, right? Because fundamentally, Go is simple. The selling point of Go is simplicity, right? And this is, for me, the selling point of any language that I can use that's simple, I will use it. Any library, any framework that's fundamentally simple, that's the selling point for me. So less abstraction, less bullshit, less abstraction for the sole sake of abstraction is always better. And this is where I think that Go shines. Even a Fastify.js that we use for Programming Network currently, it shines because writing an API is fundamentally a very simple thing. And you shouldn't take something inherently simple and make it more complicated just for the sake of that, right? So something, right? So that's, yeah. I mean, a lot of people on YouTube are asking me things about what to do next, etc., etc. I mean, if you're a young developer, if you want to be a software engineer in your career, you have to focus on, number one, on building things, and you need to work on your problem-solving skills, critical thinking, and you need to work on your soft skills. So sooner you start with this, 369, yeah, we're gonna do everything. We're gonna do pretty much everything. We're gonna implement probably some JVT or whatever. We're gonna do everything that, at least the most fundamental subsystem that any API needs. So like authenticating, error handling, maybe even logging, right? So we're gonna set some scope for ourselves. So the next 3 streams, we're gonna try to spend building something reasonable and getting very comfortable with Go. And then if people actually show interest, and I think people are interested in this subject, I can see there's 70 people watching, or around 60 to 70 today, then we can take further on and do authentication. We can do, right? And also I wanted to do this for a long time, right? Because I also want to explain, a lot of people have asked me, hey, why do you use secure cookies? Why are you storing your JSON Web Token cookies in a secure cookie and stuff like that? So there's a lot of subjects we can cover with these couple of next streams, which are not just language related, but they're also, yeah, exactly, right. We can discuss some of the security aspects, because somebody asked me in the last stream, is like, what do you use for security, right? There's no such thing that you use for security, right? Security is a complex thing that spans over many services and many things, right? So so there's indeed a lot of stuff we can discuss. There's a lot of things that we can do. So let's see. But we're gonna so for the next time, right? So for the next time, if I read the ChatGPT thing here, so for the next thing we're going to be doing, obviously we're going to need to go through pointers, but then we're going to be doing structs, pointers in Go, interfaces, composition over inheritance in Go. Very interesting, because that's what we do in JavaScript, right? Can you do a video about gRPC? I would if I knew anything about gRPC. I haven't used that protocol much. We actually at Dream Data, we're not using gRPC. We're still using HTTP. So to be very honest, I don't know much about gRPC. The thing is, and the reason why I don't know much about gRPC is that I simply didn't have a use case or a bottleneck to use it, right? So I mean, protocol is just a protocol, and I trust you, right, that all of that stuff is, yeah, protobuf and stuff. I mean, I'm familiar with the concepts. I read a little bit about it, right? But I don't have a problem that these protocols solve for now, right? I mean, I'm getting a lot of questions on YouTube which are very vague questions, right? How can I tell you how much time will it take you to be good? I mean, no, I mean, that's not a reasonable engineering question, Kumar. I'm sorry, man. I mean, what do you mean? How will I know how long will it take you? It's gonna take you depending on how much effort you put in, how many things you build and stuff like that. I mean, how can I know how? I mean, how would I know that, right? I mean, that's a very vague question. It's like saying how, you get what I mean, right? How to create protected routing in our project. I mean, tech freak, that's, again, those are such a vague questions. It's like saying, can you teach me programming? What do you mean how to create protected routing in your project? I mean, you have to start somewhere, man. You have to, right? It's like, what is life, right? You come to the chat and you're just like, what is life? What is love, right? You have to ask more specific questions. You cannot ask, how do I implement a database? That's not a question, right? That's completely vague thing, right? It's impossible to answer that. Yeah, but then he would ask, what is a middleware, right? And stuff like that, right? So when we learn Objective-C, I don't think that we will ever do that. I mean, Objective-C is a very nice language. I really love the syntax of it. It's just there's nothing that I can build with Objective-C right now, right? How do I make $1 billion? Exactly. So I think fundamentally in this stream we're going to be doing languages that I can use. Go is a language that we can definitely utilize in some services. Things like Rust and those are low-level languages for embedded development. I would never use them for anything. That's why I'm not going to just learn something for the sole sake of that, because many of you who've been following me here for a long time know that this is a very pragmatic stream. This is a very this is a stream where we actually learn things for the sake of building, not for the sake of learning, right? Because if you're learning something for the sake of learning, in most cases it's waste of time, because you're going to learn it for 3 days and then you're going to leave it and never come back to it, which means in 3 other days you're going to forget everything that you did. So here we're going to be doing Golang next couple of days, and then we're going to actually start building things in Golang, maintaining them and stuff, so we can get our hands dirty there, and we can also, yeah, just get it under our skin, right? Yeah. Need to buy me course. All right. Well, look, guys. I think that's it for today. I think I had a lot of fun. We started something new, something a little bit different. I'm gonna spend some time tonight building Programmer Network. I need to fix some things and stuff. So we're gonna, obviously this stream is always gonna be about Programmer Network, but for some time I'm gonna mix the things up a little bit, so we can yeah, have some fun and learn some new things. Yeah. Really enjoyed the stream. Good content. Awesome. Very happy to hear. Can you check the questions on Discord after stream? I can, Max. I need to eat first. I can see that my wife and my kid, they're eating. So yeah, thank you everybody for coming. This is something new. It seems that people liked it. I liked it as well. I enjoyed it. So let's continue with it. Please, if you have the time, maybe either watch this stream or go through the concepts we went already together, and so we can continue next stream and people are able to actually follow up and understand what we're doing, because I actually want you to gain something out of these series of these streams, not just stare at my face. And yeah, absolutely, Max. I'll answer it as soon as I eat. Guys, happy holidays. I'll see you guys tomorrow, and I wish you guys all the best. And don't forget to take a look at my YouTube channel. I think there's some pretty awesome videos there. So if you have some minutes to kill, give it a shot. Yeah, and cranberry wine is coming at the end of the stream, so unfortunately we'll end up. Please sign up on programmer.network as well if you can. I would appreciate it very much. Guys, I gotta go. Thank you so much, and I'll see you guys tomorrow. Peace out, everybody.